Okay guys, we've got section 5. Hey, this is our last section of the chapter. You guys have made it through your first chapter of completely remote learning. This is amazing. Section 5, we're still talking unit circle stuff. We're still obviously talking trig stuff, but what I have here is I wrote a lot of stuff out, but don't panic. You can pause the video, copy some stuff down. I'm just going to talk slowly through everything that I have written out here. So very first thing I have is I drew right triangle ABC right over here. So you can go ahead and copy that. It does say that C is the right angle and angle A is 22, so I labeled that. And angle B, that means is 68 because as you know, A and B are complementary since angle C is a right angle. That word complementary is going to be really important today. So you learned that when you were in geometry class. Remember that complements, that means that two angles that add up to 90. In a right triangle, your other two angles are always complementary because the third angle is 90 degrees. So get that word complementary in your head for a little bit. And then it says write each trig ratio in terms of A, B, and C. So remember the way that I labeled my sides are very important. So if this is angle A right here, then remember directly opposite that angle is called side A. And yes, we typically use capital letters for the angles and lowercase letters for the sides. So again, this is angle B and directly opposite that is side C. When you learned Pythagorean theorem back in geometry class, C squared was always the hypotenuse, and that's because angle C is the right angle here. So just to review a little bit of that, to write out what I did here, sine of 22 degrees. So here's my 22 degree angle, and sine, remember, is opposite over hypotenuse, and so that's A over C. And formally, now what we're doing in trigonometry is the y value divided by the r value if this were a unit circle triangle. And let's see here. So we've got cosine of 22 degrees. That is adjacent over hypotenuse. So that's why I wrote B over C. And you can kind of see that I filled in all of those ratios there. Tangent of 22 degrees is opposite over adjacent, so A over B. And then you can also see that I have the reciprocal functions here. So remember that cosine and secant go together. You just flip them. Sine goes with cosecant. They're just reciprocals of each other. And then tangent and cotangent, those are reciprocals. But what's interesting about this is what if I, instead of looking at the 22 degree angle, what if I looked at the 68 degree angle? These are arranged like this for a reason, but let's now fast forward and let's talk about the angle that I have highlighted here in red, and that's why I wrote my answers in red. Cosine of 68 degrees is adjacent to the 68 degree angle divided by hypotenuse, so A over C. But what's interesting here and what I want you to notice is that, look, I've got sine and cosine. Aren't these two angles complements? 22 and 68, those are the complementary angles. Those are the two angles of your triangle that are not the right angle. And in that case, look what happens here. We have the exact same ratio. They're equal. Did you know that if you have the sine and the cosine of complementary angles, one of them's 22, one of them's 68, the ratios are exactly the same. And so without even having to go through all of those ratios, you can, if you want to, you can look at the triangle here and be like, okay, opposite, hypotenuse, that's how we get B over C. That's the same thing, but notice here, 22 and 68, those are complementary degree measures. And in that case, cosine and sine is this new vocab word. They're called cofunctions. And the ratios will be exactly the same when the angles are complements of each other. And so what's interesting here is that you can go ahead and copy this ratio or this definition down. For cofunctions, those are complementary relationships between pairs of trig ratios. So here are the three pairs. Did you notice, like, you know, when I introduced that we have actually 6 trig functions and not 3, that they a lot of times like sound really similar to each other in a weird way, like sine and cosine. So notice how one of them is sine and the other one has sine in it, but it's just cosine. So all of these cos and the word complement, they all start with co. These are called cofunctions. So please don't get those confused with reciprocal functions. So like, I'm going to make a note about this actually so we don't get confused. These are reciprocals, and that is not to be confused. reciprocal functions. Don't get those confused with cofunctions. Those are different. Reciprocals mean you can flip them, but cofunctions, tangent and cotangent, secant and cosecant, those are your cofunction pairs, and those degree measures are complements of each other, and you get the same exact ratio when you do that. So what's interesting is you can write it like this. Sine goes with cosine, tangent goes with cotangent, secant goes with cosecant. So if you have sine of angle A, that's the exact thing as cosine of 90 minus A. That is exactly what, I'm getting like kind of crazy with my circling here. That's exactly what's happening right here. So if you have sine of an angle, that's the exact same ratio, the A over C. It's the exact same answer as the cosine, since it's a cofunction, sine and cosine, of the complement. 90 minus 22 gives you 68. So that's exactly what's happening here. And yes, in case you were wondering, you can write it as cosine of A equals sine 90 minus A. Like all of the reverses are also true, but I don't want you to have too much stuff to write here. So these are called cofunctions, and this is the relationship between them. So write each function in terms of its cofunction is what I'm going to start with now. So I've got, let's see, the cofunction of 54 degrees, or cosine of 54 degrees is equal to sine. Remember, cosine and sine are cofunctions of each other. 90 minus 54. So I just have to figure out what's the complement of 54. It's 36. Cool. So did you know that if I were to write a fraction for cosine of 54, it's the same exact fraction as sine of 36. They're equal. All right, you guys, let's look at letter B, secant. So in terms of its cofunction, so secant goes with cosecant. So I'm going to rewrite this as CSC 90 minus, and then you do need parentheses here, theta plus 17. We are going to end up distributing that minus sign, but you always do 90 minus whatever this angle is. So since this angle is actually a binomial, we have to have minus and then parentheses here. And yes, I am going to distribute my minus sign here. So I'm going to keep simplifying over here. Secant and cosecant are cofunctions, since the co is added in front of the word secant. I get 90 minus theta minus 17. So distribute that minus sign, it's going to change both of those signs. So I get cosecant. If I combine the 90 and the negative 17, I get 73, and then just keep minus theta together. And so that is actually an equivalent statement. So these are equal, this and this. And why didn't we get an answer like we did in the first one, like 36? Well, that's because in the very first example here, we were given an actual degree measure. Therefore, you can figure out the actual degree measure of the equivalent cofunction. In this case, we just have a binomial with a variable in it. The variable here is theta. And so in that case, I'm not going to have a numerical answer, but just keep in mind that it's always the cofunctions. The relationship is you take 90 minus whatever the degree is that you're given. Okay? So that's how cofunctions work, you guys. Big vocab word. Congratulations. Notice that I already have my half or quarter unit circle filled out here. This is very similar to the unit circle that we've already been filling out in class several different times in several different places. But I've got all the ordered pairs here as they are on your unit circle. And then in red out here, I also wrote the tangents. Remember, you can always find out any of these tangent values by just doing the y value divided by the x value, because the tangent ratio is y over x. But as you guys know, so this is advanced trig, and what I want to talk about right now is an advanced trig topic. So we have to talk about a little bit about increasing and decreasing for these trig functions. Increasing and decreasing is something that you talked about in advanced algebra 2. Increasing and decreasing we're going to be discussing here as well. So from 0 to 90, this means in the first quadrant. That's why I have my picture of the unit circle for the first quadrant only. So this only applies to the first quadrant. I'm going to make a little bit of a note about that. So this is first quadrant. Okay, so from 0 to 90, as theta increases, so that means as you start your theta here at 0 degrees and you rotate this direction towards 90, Remember, the theta is the angle. So remember, this is 30 degrees, this is 45 degrees, this is 60 degrees. As we rotate this direction, that's what theta increasing means. Let's think about just the y value here, because the sine, remember, is the y value. It's y over r. And remember, the r is 1 for the unit circle. So I want to compare, I'll just do this 30-degree reference, or this 30-degree reference angle, as well as this 45-degree reference angle. Let's look at just these y values here. Here's a y value and here's a y value. Can you compare this y value to this y value? Which one is bigger? It's pretty easy to see in this case that the y value here at 30 degrees is smaller than the y value at 45 degrees. You can keep writing them. What if I did this y value? Let's compare it to this one. Do you see how as the angle for theta increases this direction on the unit circle, it goes from 0 to 90 degrees? Do you see how the y value is actually getting bigger also for the triangle? So anywhere you draw a triangle in this first quadrant, the closer you are to 90 degrees, the longer your y value is. And remember that the y value goes with the sine in trigonometry. So in this case, I'm going to fill in this blank from 0 to 90. As theta increases, the y value also increases. Okay, yes, that's something that you can memorize, but you're going to have so many things memorized by the end of the chapter, the semester, whatever, that I want these things to make sense to you too. You have to be able to visualize, okay, as theta goes from 0 to 90, as I increase my angle here in this triangle, the angle of rotation, the y value is also getting bigger. That is the way I want you to kind of think about these. So let me do another one. From 0 to 90, as theta increases, what happens to the cosine of the angle? So remember, the cosine is the x value. So let's compare x values here. Let's look at 30 degrees. Here's the x value at 30 degrees. Let me use a different color here. What happens when I go from 30 degrees to 45 degrees? What's the x value there at the 45-degree reference angle? So that's weird. At 30 degrees, the x value was this long for this triangle drawn at 30 degrees. At 45 degrees, as the angle got bigger, do you notice how my x value actually shrunk? So the blue x value for the 30-degree reference angle triangle is smaller than the green x value. And even more so, if I do another color here, let's look at this 60-degree reference angle. Look how small that x value is. So it actually has the opposite effect as the sine does. So for the from 0 to 90, as theta increases, the y value also increases. The y values here are getting bigger, but the x values are getting smaller, so they decrease. Okay, and then let's talk about tangent as well. So remember, tangent is not specifically a y value or an x value. Tangent takes into account y and x. So in this case, I just want you to look at these red numbers that I have here. What's happening? So first of all, going from 0 to 1, as theta goes from 0 to 90, that is increasing. Do you know what radical 3 is? It's like 2 point something. No, 1 point something, sorry. 1.7-ish, check it in your calculator. Root 3, it's like 1.7 something. It's a little bit bigger than 1. Root 3 over 3 falls between 0 and 1. So just by knowing these tangent things, and not necessarily looking at the y value and the x value, but if you look at just the tangent ratios that I have written out there in red, going from 0 to 1 and then up to undefined, like these values are increasing until it gets to undefined. So you just look at the actual tangent values to be able to answer that one. It's the same way as the sine value. So moral of the story is, from 0 to 90, as you increase the theta, the y values get bigger, the x values actually shrink when you make the triangle, and the tangent values also increase. So we've got increase, decrease, increase. All right, so we're going to take that into account when we are looking at these last couple examples, and then I'll finish my video. or I'm going to stop the video. So sine compared to cosine. Okay, so sine of 21, 21 is not like a unit circle thing. Unit circle stuff, you're thinking 30, 45, 90, etc., like all those degree measures we have on the unit circle. So in this case, I want to kind of think about like cofunctions, and I'm going to use this information that we just talked about to help me answer this. So first of all, what I can do is rewrite this as sine of 90 minus 56. That's why cofunctions are useful. And I'm rewriting it as sine so that I can have all sines in my expression here. That's going to make it a lot easier for me to compare. So when I do sine of 90 minus 56, that changes this into sine of, what would that be, 34. So basically I'm just rewriting this cosine of 56 is equivalent to sine of 34. This is the same exact ratio as this. So I have compared, so now I can compare sine of 21 to sine of 34. Here's how I want you to think about this. Sine of 21, can you picture like where 21 degrees is on the unit circle? So let's say that's 21 degrees. Where would 34 be? It's a little bit higher, right? Can you compare those y values? Can you compare this y value to this one? Because it's sine, so remember that's the y value. So which y value is bigger? This one is smaller than this one. So remember, the bigger the angle, the bigger the y value. So that makes this false. The sine of 34 is actually greater than the sine of 21. So therefore, the little alligator mouth needs to be eating the bigger piece. So try and write them as the same trig function and then use these things up here that we just talked about. All right, let's do another one. So cosine of 89, again, that's not a unit circle thing. I don't have 89 degrees labeled on my unit circle, but I do have 45 degrees. Do you know what tangent of 45 is? Let's look right up here. I wrote it right there. Remember, the y value and the x value are the exact same at 45 degrees, so that makes it 1. So I do know that this is just 1. Cool. Tangent of 45, that simplifies. What about cosine of 89? So this is weird, but can you draw a triangle at 89 degrees? 89 is like so close to 90. It's like hard to draw. I can't even really draw a triangle out of it. It is so close to 90. But remember that the cosine is the x value. So please tell me, what is the x value there? Would you agree that it is so small that I couldn't even draw a triangle out of it? The x value there is so small that it is so close to 0. And so that's the way I want you to think about cosine of 89. 89 degrees, it's almost impossible to make a triangle out of that angle measure. So in that case, almost 0, is that greater than 1? Again, this is false. Okay, let's try this one. Sine of 50 versus sine of 40. 50 degrees looks like this. 40 degrees looks like this. Which one is bigger? The 50 degree angle has a bigger y value than the 40 degree angle. Comparing just those y values, again, because this is a sine problem, sine is referring to the y value. So in this case, the sine of the 50 degrees has a bigger y value than the sine of 40. That makes this one true. Let's talk about this one. Cosine of 46, it's almost 45 degrees. There's my triangle. This is the x value at 46. What about 23 degrees? 23 degrees is a little bit more out here, and the 23 degrees has a bigger x value. So remember, for cosine, I'm looking at the x values here. And the 46 triangle, the red line, is smaller than the 23 triangle, the blue line, that x value. So in this case, I get false. So the difference between sine and cosine is you're looking at the x value and the y value. Go ahead and sketch those triangles if you need to. But again, as the angle increases, the cosine value decreases, because as the angle increases from 0 to 90, that x value shrinks. Okay, 2 more. Sine 46, cos 46. I want to change this into sine so that I can think about all sines instead of one sine and one cosine. This changes into sine of 44. So remember, the sine is the y value. So 46 and 44 degrees are both similar. 46 degrees, 44 degrees. The y value is bigger for one of them. The y value happens to be bigger for the 46 degree angle. That makes this one false. This one's asking about the y value because I changed them both into sine. Okay, one more. Tangent and cotangent. Okay, let's change cotangent into tangent. So that makes it tangent of 49. Okay. And so this is cofunction. So basically I'm just rewriting this as this. And then what happens with the tangents again? As you increase the theta, the tangent also increases. So this is the bigger one because it has the bigger angle measure. Remember, as we increase 0 to 90, the tangent values also increase. So the bigger angle, the tangent itself is bigger. So that makes this one true. Okay, I know these are confusing, you guys. I know those are confusing. I'm going to stop there in terms of the video, and we're going to do some work and some question and answer sessions and some practicing and stuff in class tomorrow. So bring your questions to class, and we will get everything figured out then. But for the rest of tonight, enjoy the rest of your night, and thanks for watching.